Hello everyone. This is Dr. R. Sasikumar, Professor, Computer Science and Engineering Department from RMDEC Engineering College, Chennai. Today we are going to discuss about link state routing algorithm. So link state routing algorithm is an intra-domain routing protocol. Each node is capable of finding out the state of the link to its neighbor node. So how to find its neighbor node means what? Not only in a single direction, you can move either upward direction or downward direction, left side and right side, and the cost of each link. So this is the way to find out the neighbor node. Every node knows how to reach its directly connected neighbor. It has a two mechanism. One is a reliable flooding, another one is a route calculation. So reliable flooding means what? The reliable dissemination of a link state information. Route calculation, so the calculation of routes from sum of all the accumulated link state knowledge. So I repeat once again. So the link state routing algorithm is an intra-domain routing protocol. What is the purpose of that link state routing algorithm? Means it is used to find out its neighbor node. So how to find its neighbor node means what? The neighbor node can be find either in upward direction or downward direction, otherwise left side and right side also. And every node knows how to reach its directly connected neighbor. It has a two mechanism. One is a reliable flooding, another one is a route calculation. So reliable flooding means what? From a starting node, we should find out its neighbor node. That is a reliable flooding, not in a particular directions. All the directions we can find the neighbor node also. And route calculation, the calculation of routes from sum of all the accumulated link state knowledge. What are the properties of link state routing algorithm? The first and foremost property is it stabilizes quickly. It does not generate much traffic. It responds rapidly to topology changes or node failure. If any node is failure, immediately it will respond. If any node is changed, that is also given by that link state algorithm. And what is called reliable flooding? So generally flooding is nothing but what? The water will flow in all the direction, not only a single directions. The in flood during that flood time, the water will flow in all the direction. The same concept will be applicable in that link state routing algorithm. So the reliable flooding means what? It will find the neighbor node in all the direction. So it is a process of making sure that all the nodes are participating in the routing protocol get a copy of the link state information from all the other nodes. A node sent to its link state information on all of its directly connected link. Suppose if any node is connected with another node, then that information will be broadcast to all other neighbor node also. Each node that receives this information then forward it out on all of its link. This process continues until the information has reached all the nodes in the network. Suppose if you have any network means what? If you start with any node, compulsory you have to visit all other node. So that is the important property of reliable flooding. So each node create a packet called link state packet. The link state packet which contains the following information. One is the ID of that node that created the LSP. LSP is nothing but what? A link state packet. What is the ID of that node? The second one, a list of directly connected neighbors of the node with the cost. And the third one, sequence number, and fourth one, time to live for this packet. So these four is very, very important information for creating the link state packet. The working of reliable flooding, I told already, right? So the node can visit in all the directions. So LSB arrives at node X, for example, which sends to its neighbor node A and C. So A and C do not send it back to X, but send it on to B. Now the B receives two identical copies of the LSB. It will accept whichever arrived first and ignore the second as a duplicate. It then passes the LSB on to D, which has no neighbor node to flood it, and the process is complete. So when LSBs are generated, so on expiry of the periodic timer, when there is a change in the topology. So this is the reliable flooding example. I told already that the previous point, LSB arrives at node X, which sends to its neighbor node A and C. They say, right, here in this example, the starting node comes under X. The X has a two neighbor node, one is a and C. Okay. So the second point, A and C do not send it back to X, but send it on to B. Okay. So already from X, there will be a connection to A and C. Suppose if you move on to node A, the neighbor nodes are X and B. You should not visit X again because already visited. So you should find out that new node. So that's why from A, you can find its neighbor node is B. So that is the second point. And the third point, since B receives two identical copies of the LSB, because B is a neighbor node of node C and node A. So it will receive that two identical copies of the LSB, right? And it will accept whichever is arrived first and ignore the second as a duplicate. So then it passed the LSB on to D. The D does not have any neighbor node, so the process will be completed. So this is called what? A reliable flooding. So now first you should visit node X. Then this is the flooding concept. Not only moved in that right direction, it also moved to that downward direction also. So both side the control will be transferred. So X has to identify the neighbor node A and C. This is the second diagram. Okay. So the control will be transferred both upward, downward direction as well as the right direction. Now A and C will be visited. So if you consider node A, then you should find out the neighbor node X and B. X is already visited, so B is a neighbor node. With respect to node C, again we have a two neighbor node. One is X, another one is a B. X is already visited, so you should not go back. The new node is a B. Okay, but the B is a common for node A and node C. Which one is visited first? Then that will be accepted. The other will be considered as a duplicate. Okay. Then now the recently visited node is a B. From B, only one neighbor node D. So compulsory we have to visit all the node. Once you visit all the node, then you stop the process. So I will give that example. Okay, there are four nodes available, A, B, C, D. You can start from any node. Either you can start from A or B or C or D. Okay, if the node A is connected to B, the cost is 5. If the node A is connected to C, the cost is 10. If the node B is connected to C, the cost is 3. B is connected to D, the cost is 11. C is connected to D, the cost is 2. So we have a table. The table which contains four properties. One is a step, the another one is a confirmed, the third one is a tentative, fourth one is a comments. Okay. So you can start from any node. So either A or B or C or D. For example, if I am starting with the node D, okay. So it has a 3 parameter D, comma, that is a first node is nothing but what? A starting node. And the second is nothing but what? To reach D, what is the cost? So self node, I already told in that distance vector algorithm, to reach self node, the cost is 0. And the third parameter indicates via, what is the next hop. So the D can be reached by same node itself. So the next hop is not available. So empty. So this is what a confirmed state. Okay. Now I should start with any node. I can start with the node D. To reach D, the cost is 0 via no hop. So that is empty. So now since D is the only new member of the confirmed state, from D we should find out the neighbor node. So what is the neighbor node of D? C and B. Okay, from D to reach B, the cost is 11. From D to reach C, the cost is 2. So now the second step, the confirmed state is what? D 0, minus, sorry, dash. Okay, from D you can visit B. The target node is B. What is the cost? Second parameter, total cost 11. What is the next hop? No next hop, directly connected. So the next hop is B. Another node is what? To reach C, the cost is 2. What is the next hop? Directly connected. So C. So from with respect to node D, we can reach B through B, cost is 11, which is better than anything else on either list. So which one is the least cost? Okay, so to reach B, the cost is 11. To reach C, the cost is 2. So which one is a less cost? That will be moved to confirmed state. The remaining will be retained in the tentative state. Okay, so according to this example, to reach C, the total cost is 2. So C is less than B. Now the C will be moved to confirmed state. Okay, so the confirmed state already D confirmed. Now C, to reach C, the cost is 2 via C only. Okay, now the recent visited node is C. From C, we have a already in the tentative node from D to reach B is 11 via B. Okay, and the next one, the recent visit node C. From C, we should find out the neighbor node. So with respect to node C, the neighbor nodes are B, A, D, but you should not go back to D because D is already visited. With respect to C, node B is a new node, node A also new node. Okay, but the origin is what? D only. So the total cost will be accumulated. Already from D to reach B, the total cost is 11. But via C to reach B, the total cost is what? D to C 2, from C to B 3. So 2 plus 3, the total cost is 5. Okay, so which one is the less cost? That will be updated in the table. Now in fourth step, to reach B, the cost is 5 via C. Again from C to reach A, what is the cost? To reach A, the cost is D to C is 2, then C to A 10, the cost is 12. So to reach A via C, the cost is 12. What is the next step? We have a 2 node. So which one is the least cost? That will be transferred to confirmed state. The other will be retained in that tentative state. Okay. Now the fifth step is D already confirmed, C already confirmed, and recently B is confirmed. What is A? To reach A, so far the cost is 12 via C. But which one is visited recently? Node B. So the sixth step, with respect to node B, you can visit A. Yes, it is possible. So from D to B to reach A, the cost is 11 plus 5, 16. From D to C via B to reach A, the cost is 2 plus 3, 5, 5 plus 5, 10. From D to C via A, to reach A, the cost is 12. So we have 3 different costs to reach A from D. One is a 16, another one is a 12. Via C and B, the cost is a 10. So which one is the least cost? 16, 12 and 10. 10 is the least cost. So to reach A via C, the cost is 10 because from C to A, not directly, via B only, because the B is the recently visited node. So with respect to B, you can find the neighbor node. There are 3 neighbor nodes available with respect to node B, but C and D already visited. You should not go back. Only forwarded allowed, forward direction only allowed. So A is the neighbor node. So via C and B to reach A, that is the total cost is 10. So that's all. We have visited all the node. Now the tentative node, what is available in the tentative node, that will be moved to confirmed state. So the last step, all D visited, C visited, and B also visited. Then finally A also visited. So this is the way to find out the link state routing example. Thank you.